Hello everyone, I am Professor Sagar Pokharkar from ENTC Department of ASSMS Institute of Information Technology, Pune. So today I will give the introduction about the electrostatic boundary value problems. So in previous units we find E bar, D bar or V or any other electrical quantity or electrostatic quantity by using either Coulomb's law or Gauss's law. But we shall consider a practical electrostatic problem where only electrostatic conditions, that is charge and potential at some boundaries are known, and it is desired to find E and V throughout the region. Then we cannot apply here in such cases the Gauss's law or a Coulomb's law. So to tackle such problems, or such problems are usually tackled or you can say handled by using the Poisson's or a Laplace equation or the method of images, and they are usually referred to as the boundary value problems. So example of such problems include capacitance and vacuum tube diodes. So the Poisson's and Laplace equation are easily derived from the Gauss's law. So we know that del dot d bar equal to rho v, and we know d bar equal to epsilon naught E bar. So here we put that values. Then we know that E bar equal to minus del V. So by substituting these value in above equation, we got del dot into minus epsilon del V is equal to OV. So for a homogeneous equation, now the equation becomes del square V equal to minus rho V upon epsilon. This is called as a Poisson's equation. Now, the special case of this equation occurs when rho v equal to 0, that is for charge free region. So now the equation becomes del square v equal to 0, and which is known as Laplace equation. So Laplace equation in a different coordinate system you are seeing on my screen, which are these. So first equation for Cartesian, second equation for cylindrical, and third equation is for spherical coordinate system. So these are the derivation for each coordinate system, that is called the Laplace equation for different coordinate system, which are in terms of v. Now we see the general procedure for solving the Poisson's or Laplace equation. So step number one, solve the Laplace. Now we can solve by using the two. Either we use the Laplace or either use Poisson's. But we know that if rho v equal to 0, that is Laplace, and if rho v is not equal to 0, then we go for Poisson's equation. So first a part in that, direct integration when v is a function of one variable, then separation of variable if v is a function of more than one variable. The solution at this point is not unique but expressed in terms of unknown integration constant to be determined. That means here the constant of integration occurs, but by using the boundary values we can obtain that easily. So apply the boundary conditions, second step, apply the boundary conditions to determine the unique solution for V. Imposing the given boundary condition makes the solution unique. Now third step, having obtained V, find E using E equal to minus del V and D from D equal to epsilon E. So if desired, find a charge Q include on a conductor using Q equal to rho s ds, where rho s is equal to dn and dn is the component of d normal to the conductor. If necessary, the capacitance between the two conductors can be found by using C equal to Q upon V. So this is the general procedure to solve the problems, and such a problem is called the boundary value problems, and for that in short we can say we use the Laplace and Poisson's equation. Thank you.